Does that make sense? So I need to see this just so I can give you part marks if I'm like, okay, at least you got the parent function right. So I can give you like a half mark. Okay, you got the parent function right. Here I need to see the formula. So I'm like, okay, you got the 1/2. Good. So I can give you another half mark for writing something. And then plug it in. Again, it's up to you if you want to show the work on that or if you just want to plug it in and give me the answer. The y's are all the same, right? Nothing changed on the y. For today, right? For today. Tomorrow it'll change. These are the points. So this is my new point. 1, 4, so -2, 4 has now been mapped to 1, 4, right? -1, 1 has now been mapped to 1/2, 1. So when we plot this guy here, right, when we plot this guy here, we go this, so my vertex is still at 0, 0. So look, my vertex didn't change, so that's still at 0, 0. The vertex is the vertex. 1/2, 2, or sorry, 1/2, 1, so 1/2 is now 1. Okay, 1 is 4, at 1 it's at 4. And at -1/2 it's at 1, and at -1 it's at 4. And when you graph this, I'll use a dark blue. You can see it's half as wide. Oh, shoot, did I lose a negative? Oh, it's horizontally reflected. No, nothing. Yeah. So for a parabola, a horizontal reflection did nothing. I was like, wait, wasn't I supposed to reflect it? I just forgot. We talked about that before. It does nothing. So the negative there got taken away, and it ended up being nothing, right? So the horizontal reflection changed nothing. Okay, so that's the parabola. Yep, question?
I honestly completely forgot what I was going to ask.
Okay, ask again when you remember.
Okay.
All right, let's try again. Right, after we do a few, it feels a little bit better. The first part of this is like, what is happening and why are we doing this, right? Because it's our first shot at this, very first. Okay, so that's the parabola. Not bad. Okay, okay. Let's do this. Yep.
How many points would have to show to get a full mark?
For this one, oh, good point. Yeah, good question. I would say on a parabola, I would go for 5. So a parabola, right? So a quadratic, 5 points, right? Because you kind of do the vertex, 2 and 2. So always try. If you can't fit it, like if I vertically stretch it and you can't fit it, you can't fit it. But on the chart, you were like, I tried, and look, it went off. So I would look at your chart and go, good, you tried, and then, but you couldn't graph it, so that's okay. Yeah, so 5. Good question. Yeah, we'll talk about the number of points for each one of these graphs. So quadratic, 5 is a good, always go. Vertex, vertex, and then 2, 2 on the side. Yeah.
My question is, will there ever be like, because right now we're doing where it's like stretching and compressing.
Yep.
Will there ever be questions where we're actually like moving the parabola?
Yes. Yep, we're going to do that in 1.8. So 1.7 is just concentrating on this whole reciprocal thing, which throws everyone off. They're like, why? Right? And it's just because that's the only way we can get it to graph. We do the reciprocal. We get used to that idea. And then 1.8, we're going to do everything. Left, right, up, down, reflect, and stretch and trace. Just the whole, yeah. Yes?
For the new function,
Mm-hmm.
if you only get like a certain point, do you have to continue the parabola until it's at the top of the graph?
You want to,
Arrows.
yeah, you want to do arrows, and you want to try to do it as long as possible. Yeah, yeah. So try not to make it too short. That's all. Yeah. For this one, 3 points. We're aiming for 3 points. Right, so we're going to do our little chart. So I usually do my X here. My Y is just my Y, so my Y will be the same. Right, Y will not change at all. My X is going to be, so in this one, because it's square root like this, because it's that lovely square root, we know that the parent function is the square root function. Does that make sense? Right, sorry, right there off the screen, square root function. You can recognize it. Okay, so my points, and we're going to do 3 points. Let's aim for 3 points for this one. We have the starting point, which is at 0, 0. Can you see the pink, or is that too light? Maybe I'll do back here. Right, so 0, 0. What's another point on that square root function? 1, 1, you remember, right? And then, yep, I'm going to graph it here. And then 4, 2. So 4, 2. Okay, just the 3 points. So again, that's why we wanted you to memorize those parent functions, because they're right there. So from the parent function, we have the 3.001142. We're going to take each one of those and transform it. So my formula for this transformation would be, what do I do to the x? Not 1/4, but 4. 4 reciprocal times x. I'm stretching it horizontally by 4. Okay, so then take my values. I'm going to plot them in, put them in here. If I put 0 in for x, I get back 0. If I put 0 in for y, I get back 0. If I put 1 in, I get 4. If I put 1 in, I get 1. Is that okay? This one's easier to do. 4 times 4, 16, 2, there. So these are my coordinates, right? So these are my coordinates now, x, y, x, y. So 0, 0, 4, 1, and then look at that, I can't fit 16, 2. But I tried. So you show me here that you tried the 3 values. I couldn't plot it, but that's okay. I look at your chart, and this is, I give you marks for that as well. I'm like, okay, good, you got the formula, and you plotted it, and we're good to go. So then it's stretched horizontally long. And yes, try to make, don't stop the arrow at 4, right? That's what your question was. So don't stop it at 4, try to make it longer, right? So a little bit long. Try to fill the graph, yeah.
Oh, why did you flip it if it's not the bracket?
It is, the square root is the bracket. Remember, square root acts like a bracket. What do you do there? The square root is the bracket. The square root is the function. So it's not squared. Squared is squared, and this square root is like a bracket.
The square root is like a bracket?
It's like a bracket, yeah.
So for the next one, you wouldn't flip it?
No. Okay. So that's okay for this one? All right. So the next one, it's on the bottom, and this bottom part is the part that's going to be horizontal. So anything below is going to be horizontal. So that works like an invisible bracket. So this part is all the horizontal. So that's the horizontal part there. Okay? So anything below it is horizontal. Anything above it or to the side will be vertical. So when it's in the bottom, that's like a bracket. It's in the bottom, it's the reciprocal part of the function.
Is this parent function 1 over x?
This is, yeah, the parent is y equals 1 over x, exactly. The parent function is 1 over x. This one, I need 3 points on both sides of the graph, right? So we have 3 and 3. So this one's going to need 6 points and 2 asymptotes. Okay, so I want the 6 points and the 2 asymptotes. So this one's the big one. This one's a longer one because you got to do both sides. It's like a double graph, right? So they match, which is good, but there's going to be 2 parts to it. Okay, so let's do our chart. This one's going to be a bit longer. So for this one here, okay, the y again is just the y. Nothing's changing for today. But the horizontal here, the denominator makes it part of the horizontal. So we're going to do the reciprocal. So what do I do for my formula here? What will it be?
1 over 2?
No, 1 over 2 is the number. 2x, yes, 2x, the reciprocal. So 2 times x. That is the function. That's part of the parent function, right? So the 1 over x is the parent function. So this is the parent function. We're talking about just who's with the x. So who's with the x is the 1/2 x. The 1 over x, 1 over part is the parent function.
So the x is the part you're transforming.
Horizontal, yes, yeah. That's a horizontal transformation. So whatever's with the x is horizontal. Whatever's with the x is horizontal. So that's a horizontal transformation. 1 over is the parent. So that's where we're getting our original points from. So the original points that I want to transform are 1/2 is 2. Okay? 2 becomes 1/2. 1 is 1. Okay? Then I also want negative 1/2 is negative 2. Negative 2 is negative 1/2. And negative 1 is negative 1. Okay, so we're making that a bit longer. The other thing I want to add to this chart also is Okay, so we're going to add here y equals 0 and x equals 0, because those are, okay, so those are part of what I'm transforming. So I always add those either below it or around it, so I know that we're transforming those as well. Sorry, I should have moved that up a little bit. Okay, so we're going to transform each one of those points. One sec. Okay, so we're going to take the 1/2 and put that in. Now, what I would do is I would actually start with the asymptote. Y equals 0, is that going to be transformed? So I put 0 in for y. No, y equals 0 has not moved. So I put y equals 0 into y, it's still y equals 0. So y equals 0 will still remain where it is. Okay, so that y equals 0 remains where it is. That has not changed. Y equals 0. And that's what I meant by labeling your asymptotes. So some people on the quiz did not label that with the dashed line and the equation, right? So losing a half mark for that when you don't do that each time. And then here, when I put x equals 0 in to 2x, what will happen? What's 2 times 0? Still 0. So it did not change my asymptotes. Okay, so that still stays the same. Okay, take each one of the points and put them in. So 2 times 1/2 is 1. 2 goes in here. 2 times 2 is 4, and that's 1/2. Right, 1 goes in, so it's 2 and 1. Those are 3 points. So if you want, you can pause and plot those for a second, because that's part of my graph already. So I know at 1, it's at 2. At 4, it's at 1/2. And at 2, it's at 1. And look what happens. So we get the same graph, but it is stretched horizontally a little bit wider. Just looks like it's been pulled horizontally a little. Do the same with the next points. So negative 1/2 goes in, you get negative 1, that's negative 2, negative 4, negative 1/2, and negative 2, negative 1. So when I plot those, negative 1 is negative 2, negative 4 is negative 1/2, and negative 2 is negative 1. So the graph, when transformed, should still have the same shape as the parent function. So you know there's asymptotes, all that sort of stuff. And the points should line up nice and symmetrical. That's why you know you've got kind of the right calculation at least a little bit. Okay, and you're showing me the steps. Okay. It always feels really weird at first. Okay, so that's why. When we finish the rest of 1.7, it'll feel a bit better. I'm just going to pause here.